Good afternoon, organizer and participant of the conference. The result of the research are brought to your attention. They relate to methodology of operative setting of mass crystallization parameters of gas hydrate in reservoir system. The product of hydrocarbon is accompanied by formation of undesirable solid collateral structures, gas hydrates. In this regard, there is a need for constant and operational monitoring of hydrate formation parameters in production and product preparation systems. But the thermobaric parameters of the significant part of the technological chain of extraction and preparation of hydrocarbon lie in a narrow range of equilibrium condition of hydrate formation. Moreover, system parameters can change constantly and quite dynamically. So the process defined need constant support in the form of operation monitoring of their parameters. However, classical methods provided for fixing the equilibrium parameters of hydrate formation and the moment when the system reaches equilibrium. In most cases, the speed of fluid flow in technological line and the dynamics of change in its parameters in no way allow the system to reach an equilibrium state. The goal of the work is to develop a methodology and appropriate equipment for quickly setting the parameters of mass crystallization of gas hydrate in reservoir system that have not reached a state of equilibrium, as well as to substantiate the design of laboratory installation for its implementation. There are several experimental methods for determining the parameters of gas hydrate phase equilibrium. For example, the visual control method, the graphical method, computer modeling, as well as a number of the latest technologies that require special equipment due to simplest the isochoric or T-cycle method are widely used. But all the methods are based on the establishment of equilibrium thermobaric condition for the formation of hydrates. Even computer simulation may not predict metastable state occurring under certain thermodynamic condition that may be common in hydrate reservoir. Therefore, for effective control, it is important to set the parameters of the process at the moment of the beginning the consolidation of gas hydrate crystals, the stage of their massive growth. The process of hydrate formation occurs most intensively at the interface boundary and is visually manifested after the certain induction period from the moment of mass crystallization in the form of a hydrate film. Visual, the process is fixed by the transformation of the mirror surface of the interface boundary into the matter one. In addition, in the course of research, it was established that the most effective thing of the formation of microcrystal gas hydrate on the surface of the bubble in the distortion of the reflection of the light source on it. The dynamic of the mass crystallization initiation process is illustrated in page number 6. Taking into account the requirements for the design of the reactor unit of the installation for the implementation of the methodology for setting the parameters of mass gas hydrate crystallization. A laboratory installation was developed and manufactured, the diagram of which is present in page number 7. In page number 8, a photo of the reactor unit of the installation and its element is present. During the experiments, it was established that in the first case, number A, the most active mixing takes place in this area. In the second, B, and third, C, cyclic wetting of the capillary walls with a film of water. That is the formation of a new interfacial contact surface. At the same time, most often the first signs of the solid phase of the hydrate were recorded in the zone of bulb breakthrough to the surface. Thus, according to the methodology, the appearance of one, the science is identified as the investigated moment of the beginning of mass gas hydrate crystallization under the thermobaric condition. The result of testing the methodology on sample natural gas of a typical composition are presented in page 10 and 11 and 12. The analysis of the experimental and calculated dependence show that the deviation log of the experimental date from the calculated date is predictable since the studied system, according to the research methodology, doesn't reach an equilibrium state at the time of fixing the crystallization parameters. The parallel arrangement of the trajectory of the curve indicated the higher accuracy of the obtained experimental data. And conclusion. In the course of experimental study, the method of operational setting the parameters mass crystallization of gas hydrate in reservoir system that have not reached a state of equilibrium is substantive, is done by visual identification of the appearance of a solid phase at the interfacial surface of the gas bulbs. A laboratory installation has been developed and implemented. The proposed method allows you to quickly obtain objective information about the possible behavior of the system in the case of intensive change in parameters in non-equilibrium condition. That's all. The report is finished. Thank you for your attention.